Alrighty, guys. So this week, like I said, we are working on chapter 3. So this is actually, one of the first chapters where we get into calculations, because so far we haven't really, focused so much on calculations. It's been about, of course, learning the terminology and the different concepts of statistics in that first chapter. Second chapter was more about creating tables and charts and graphs, that sort of thing. So now we're actually getting more into the calculation side of it. So chapter 3 focuses on measures of central tendency, measures of dispersion or variation, and measures of position. So that's going to be the big part of chapter 3. And, of course, stuff surrounding it. So as you can see, we'll be talking about the shape of our distribution. We'll be getting into the center, the spread. So again, you have reading and viewing assignments for chapter 3. So I would definitely recommend you to look through those. You also have a discussion post and an assignment in D2L. And then of course you will have my stat lab assignments, the homework quiz and the exam. So again, if you guys will take a quick second and shoot me an email requesting your password for this week. As soon as I'm done with class, I'll send those passwords out. So just do a quick email requesting your password for this week. So again, you don't have to wait till the weekend and ask me for your password. So take a quick second and do that, guys. And I also wanted to let you know, just in case you're not aware, after each lecture, I come back to this section right here. So, under week 3, when you come back to this interactive session area, I will actually post the recording of our class right here underneath this section. So that way, whatever concepts we go over, whatever, discussion we have, you guys are able to go back and look for that, if you need extra help or go over, what we talked about, that kind of thing. So just remember, it's going to be under each week, it's going to be under these interactive sessions where you'll find the recording for our lecture. So here are your reading and viewing assignments. So, as always, you will have the reading from the textbook and then the handouts that I have created. So you can always look through that. And then under the viewing assignments, I've got the crash course statistics videos, and then these are the videos that I have created, for the chapter 3. And then at the bottom here, guys, you will see that I have also included a video that shows you how to work a problem in one of your homework assignments. So this is problem number 2 from section 3.3. So, anytime students ask me questions about homework, and I think if it's a problem where I need to actually work it out and show you how to break it down, then I post those right here under the viewing section. If it's a simple question, then I can just reply back in the email. But if it's a question where I actually need to work the problem out, then usually those are the ones I'll post here because I create videos for those. So this is going to be under the viewing section for chapter 3, where you'll find that homework help. So that's under view. And then, like I said, for this week, your discussion and your assignment in D2L. So this one over here talking about the average American, since we are working this week on averages. So when we talk about measures of central tendency, that means we're talking about averages. Now, remember, average is like a blanket term. There are 4 different calculations that you can use when you are working with averages. So, we have the traditional one, which is what we call as mean. That is where, you add all the data values and divide by the total number of items you have, which is normally what we think about, when we think of an average. So that's what we call as a mean. Then you have the median. The median actually depends on the position of your data item. So you set them, in order, and then you try and find the centermost position. So the median is based on position. You have mode. Mode is what we think of, what's the most typical number that occurs, or the typical case. So mode is where a number that may occur the most often, right? That would have the highest frequency. So that's what you think about in terms of mode. And then we have one more measurement, which is what we call as mid-range. And mid-range is where you take the lowest data value, add it with the highest data value, and you divide by 2. So as you can see, each of these calculations are very different. And depending on the data set you are working with, you will have to choose, should I use mean, median, mode, or mid-range, which would be a good representation of the data set I'm looking at. So that's where this idea of the average is coming from, right? So our discussion is based on a podcast where they actually talk about how they can find who the average American is. So again, guys, if you did not change your settings last week for the discussion post, I'll put those instructions in here again. We do not want you to include the original post in your reply because, like I was telling you, it just becomes too long for me to read through everything. So if you haven't changed your settings, please do that this week. So talking about finding the average American, this was kind of a neat podcast because they were talking about, how would you go about finding the average American? Like, what would the process be, right? Because it's not an easy task when you think about an average American. So basically, what I want you to do is before you listen to the podcast, I actually want you to describe who you think the average American should be. And this is not a scientific question. So this is not based on how would you find the average American. When you think of an American, what comes to mind? That's what I'm asking you about. So would it be someone like you? Would it be somebody else you know? Think about what do you think when you say, oh, he's an American, or she's an American? What kind of image comes to your mind? And then the idea is to make that comparison with what the podcast had to say. So thinking about the average American, I'm giving you some guidelines here. So think about, how old do you think this person would be? What would their gender be? What race would they be? Would they be married with kids or not? What would be their highest level of education? What kind of income would they have? And then once you have kind of gone through your idea of this person, then you can kind of say, okay, which measure of central tendency would you use? So which calculation would you go with, mean, median, mode, or mid-range? So and I don't want to give you an answer from my end because I don't want to influence your answer. So I'll talk about this maybe later on. But yeah, come up with your own average, what you think this average American would look like. And then once you have that answer written down, guys, then you can go back and listen to the podcast. As you can see, it's not a very long one. And, they go through a bunch of different descriptions. So they describe how they did different calculations, how they did different studies, and what the answers came up with, and how those answers were so different from each other. And then, they talk about how they took some of the parameters and changed them so they could get a little bit more of a better description of who the average American should be. And you will be making discussion points based on, what they're talking about in the podcast. So once you're done listening to the podcast, of course, you're doing a comparison between similarities and differences between their average American and the average American that you chose, as part of the first question. Then, like I said, there are going to be many different average Americans that they talk about in the podcast. So they're going to talk about, first we had, this age group or this person or this demographic as our average, but then we realized this was not working. So we changed it. And then we came up with this. So, talk about some of those different average Americans that they talk about in the podcast. And then the last part here is actually going to be if you have to find the average of anything. It can be whatever you are interested in, sports, movies, music. Oh, Caitlin. Oh, I'm sorry about that. Yeah, I'm telling you, technology is just not serving us right this week, or at least not me for sure. So, what would you find the average of? So, just pick again, kind of like you guys did with the survey discussion last week. Just pick whatever you think would be interesting for you, what you would want to find the average of, and then think about, okay, so what would that item be? What would you choose? And what measure of central tendency would you use? And, of course, I would like you to give me a little bit more idea of why did you choose this specific item, and the measure calculation that you went with. So again, your discussion post, the initial post is due tonight at midnight, guys. And then the peer replying to 2 of your classmates at the minimum, more if you want to get extra points, will be due on Thursday by midnight. And again, you've got some guided questions to help you out over here. So, that's kind of what you are working on this week as far as your discussion post goes. And then here is the activity you will be working on. And, of course, we are still working with averages, dispersion, spread. So that's kind of where our assignment is going to focus on this week. So again, just some initial information about measures of central tendency, measures of dispersion, some videos to help you out again. But here, we're trying to understand basically how to perform these calculations and how to gather information, after we have done the calculation. So what can we get out of that? So what I've done here is I've basically given you the list of all the ages of the US presidents that we've had, and how old they were at the time of their first inauguration. So these ages are listed horizontally. So as you can see, George Washington would be, the first president. So he was 57 at the time of his inauguration. This list goes horizontally. So these are the first 10 presidents, then, the next 10. So 11 to 20, 21 to 30, 31 to 40, and then 41 to 45, even though Joe Biden is the 46th president, the reason you only have 45 numbers here is because Grover Cleveland served 2 non-consecutive terms. So he was president twice, but he didn't serve them, consecutively. So only his age from the first inauguration is listed. So the second time he became president, that age is not listed. So that's why you have one age short, over here. So this is basically your data that you are working with, these numbers here, but I did include the document from where I got these ages. So this was actually a data set that StatCrunch had. And so you can see they've got a whole lot of information over here, but we just went with their ages. So you can kind of see that whole list. So you're not really using this file, or rather this document over here. You are using this file because you do have your template in the second tab over here. So technically you're using the file, but you're just not using this original data because, I've already given this to you right over here in the description itself. So these are the ages you're going to be working with. Just keep in mind that you are rounding all your answers to the nearest 10th because, some of these calculations will give you more decimal places. So make sure you round them to the nearest 10th. So what you are doing is actually in phases. So let me go ahead and actually make a copy of this. Because again, I don't want to kind of mess around with the original file. Okay, and I'll share this with you. So if you guys want to work around with me, you can do that. And make sure you've got editor. Okay, so I'll send this through chat. Okay, so you should see the link for this document coming through chat on Zoom. So you can get into this file and, like I said, play around with it if you like. And we actually need to be on the second page of this document. So the first one is just for information. And again, you will see here, guys, in the template, I have actually gone ahead and put those ages over here already, so you don't have to copy that over. So all those 47 ages from, George Washington to Joe Biden are already listed over here on the left-hand side. So what you are doing here, as you can see, part one, I'm asking you to calculate the mean, median, mode, and mid-range. So those are the measures of central tendencies, right? Those 4 calculations. Then, excuse me, you are also doing the range and standard deviation, which is the measures of dispersion. So, they talk about how spread out your data is. So those will be, what is that? The 6 calculations you will be doing for all the ages for these 45 values that you have here. So that is the information you are going to be putting in here. So you will be calculating the mean, median, mode, mid-range, and then range and standard deviation, which come from your measures of dispersion. The N, stands for how many total data values you have. So for the N, you can actually use a very simple built-in calculation, which is the count function. And the count just helps you count how many values you have in your data set. So if I go ahead and place that count, and I don't know why that cell is there, and then, just go ahead and select all of these ages on the left-hand side column till you get to the last one. Close your parentheses. So you can see it has selected all of those ages, and it should give us the number that we have, which is, 45 different ages that we have here. So that's the count function. And as you will see here, at the bottom of our table, I've actually given you a list of built-in functions that you can use to find some of these values. So when you guys work on your homework, it will actually have you do some of these calculations by hand, and I do encourage you guys to do that, because you should be able to do these calculations by hand. At least when you have a smaller data set, you should know how to calculate mean, median, mode, mid-range, range, standard deviation in the most basic fashion. But when it comes to larger data sets, I'm okay if you want to use Google Sheets or Excel to solve them, because the way I look at it, guys, is basically, if you were going to be in the field, if you were going to be statisticians, or if you were going to be doing these calculations for any reason, you would not be doing it by hand, right? We would be using calculators or data sheets like these, or some kind of technology. So I'm okay with you using technology, but like I said, it is always a good idea to have a working knowledge of how these formulas and these functions work out by hand also, okay? So like I said, you have these given to you. So in case you don't remember, you can always come down here and look at them. So that's the count, which tells us, okay, so we have all of our 45 ages, none of them are missing, we're good to go. Now let's talk about how to calculate the mean. So again, if you look at the list here, the built-in function is called average. So again, we will do equal to, type in average. And then same thing, once you put that average function in, same thing, we're still selecting, because we're finding the average for all of these ages, right? So go back and select your entire column with the ages of the precedents. And then, you know what, I'm actually going to go ahead and copy this so I don't have to keep, selecting my cell. So once you put that in, hit enter. So right now, the average age for all of the 46 precedents we've had is going to be 55.5. And, of course, we're not including the second time Grover Cleveland became a president, right? We're just using his first age. So you can see what the average function does is basically added all the values together and then divided by the total number of data items we have. If you want to verify that, again, let's go ahead and add all of our, precedents ages. So we can go ahead and add all of those precedents ages and then divide this number by how many precedents ages do we have? Well, 45 of them. So divided by 45, and you will see this number, rounding it to 1 decimal place, comes out to be the same thing when we use the average function. So you can see, even doing it the traditional way, we still get the same answer as when you use the average function. So, again, just a quick way to verify that our calculation is on track. Now, for the median. Now median, guys, remember, is where you technically set up all your data values in order. So if we had to do that, let me show you how to do that here on the next sheet. So again, I don't really want to mess up with this guy. Okay, let's open just a new blank sheet. Paste it here. Remember how I showed you to sort it last time? So select that column. When the arrow appears, go ahead and sort it from A to Z. So that would put it from smallest to largest number. And you can see this is coming out to be, 42 is the youngest age that we had for a president. And I believe Joseph Biden is the oldest president we've had at 78 years old. So he would be the oldest at the age. So the way median works, let me get my pen going here. So for the median, we usually have to find the position or the location of where the median is going to be. So for the location, we actually use this little formula, which is n plus 1 divided by 2. And n is going to be, how many data values do you have? So of course, our data set, n is equal to 45 because we have 45 ages in here. So then we can basically end up doing, okay, 45 plus 1 would be 46. And 46 divided by 2 would give us what, 23? So our median, once you sort your list from the smallest to the largest number, is actually going to be in the 23rd position. Now, again, the best thing about Excel or Google Sheets is you can see I started at the very top column, very first cell. So you can see that corresponds to box number 1, right? So to find the 23rd position, since I don't have any other numbers kind of in the way, you can actually go down to the 23rd cell. And that tells you the age in the 23rd position is going to be age 55. So this is the 23rd position. That's not your median. That's just the position where you will find the median. Okay, so your median is going to be 55. So the median age or the centermost position of the age is going to be 55. Now, just to let you know, while we are on the discussion of this formula, let's say we had all 46 ages, right? Instead of leaving Grover Cleveland's second age out, let's say we had included that also. So when you use this formula with an even number, guys, of course, as you can imagine, 46 plus 1 will end up giving us 47. And when you divide 47 by 2, what will that give us? 23.5. So you are actually going to end up in 23 and 24 because 23.5, of course, is a number between 23 and 24. So you will actually be looking at the 23rd and the 24th positions, which means when you find the median for something like this, we would have gone with 23 and 24. And you would have taken both the ages, which that one also happens to be 55. And for the median, for this one, you would have actually taken both of those ages, added them together and divided by 2, which would have actually, again, given you 55 since both the numbers were the same. But if they were different, then, do the calculation and whatever that answer comes out to be, that would be your median age. Let's say, instead of this being 55, what if this guy was 56? Well, then you would have added 55 plus 56, taken its average, and that would have come out to be 55.5. So just remember that whenever you have an even number of data values in your set, you will actually come up with 2 positions that then you will have to take an average of to find your median. If it is an odd number data set, then you will only end up with 1 position. And then, that of course will give you the answer for your median. So that's how traditionally the median calculation works out. So Now that we know our median will come out to be 55, let's go ahead and see what will we get when we do this. I'm just going to copy this so we can use that in our calculation here. So for the median, again, you will do equal to. You can see the built-in function is also called median. So we will go ahead and say median, put my cell numbers in here for the ages, close that and hit enter, and you will see we came up with the same answer of 55 as we saw on the other page. So again, that's your median. Now for the mode, remember how I was telling you we talk about mode in terms of which number occurs the most often, so which one would have the highest frequency. So when you are working with mode, typically you can create a frequency distribution table and see which age has the highest frequency. But we can kind of do that right now visually if we wanted to. So you can see, the 40, 42, 43, 46, 47, 48, 49. The largest maximum occurrence I'm seeing right now is 51. So you can see that's 1, 2, 3, 4, 5. So 51 has a frequency of 5. Let's see, 52, 54, 1, 2, 3, 4, 5. 54 also has a frequency of 5. Okay, let's go down further. 54, 55 is only 3 times, 56, 57 is 4 times. 58, 61 is 3 times, 62, let's see, 64, 65, 68, 69, 70, 78. Okay, so the highest frequency it looks like we are seeing is on 51 and 54 because we had 5 different precedents, at 51 and 54 ages, so for a total of 10 precedents. So that is your highest frequency. Now with mode, keep in mind, guys, you can have a data set which is unimodal, which means you only have one mode. You can have bimodal, which is 2 modes, or you can have multimodal, which means you can have more than one mode on these data sets. And that's kind of what it looks like from our calculation here, that we may have a bimodal data set. So what I do is by default, when you're working with the mode function, I actually use the multi-mode built-in function to work with this. And I'm actually going to do that right here on the side. And I'll show you why I'm doing it on the side and not in our table. So equal to, and I'm going to type mode. So you can see it shows up with multiple options here. You have the mode, you have the mode.mult, which is for the multiple, or mode.single, for a single one. So by default, I just go with multiple mode. So that way we know if we have more than one number, it will show up. So I'll do the multi-mode and then go ahead and put our data set in there, close parentheses and enter. Oh, didn't need to do that there. Okay, there we go, that should work. And you will see it lists those numbers underneath one another, right? So you got 51 and 54. Now, just to show you, if you just use the mode without the dot multiple option and you just did the mode, we'll put our data set in there, hit enter. You will see it actually only gives you one number when you just use the mode function. When we use the multiple mode function, we came up with 2 answers. So that's the reason why instead of mode, I end up using multiple mode. So what I'm actually going to do here is type in 51, 54. So we know this is a multiple mode method, data set. So that's your multi-mode. Now your mid-range, unfortunately, your textbook, the one we're using for the class, does not talk about mid-range. And I don't know why some of the textbooks do that. Some of them will talk about mid-range, some don't. But that is a valid calculation for an average. So we will still talk about the mode mid-range. So there's actually no built-in function for mid-range here, guys. So what you actually have to do is figure out what your lowest and highest data values are, add them together, and then divide by 2. So we'll kind of create our own little built-in function. So to find the maximum and minimum values, you have the max and minimum functions, which are built into Excel or Google Sheets. So what you can do is we can say equal to, then actually in parentheses is where I'm going to type in my max and minimum. You can use brackets, you can use parentheses, doesn't matter. So I'm going to do maximum for our data set, which we know is going to be 78 years old because that is the oldest age we have. So the maximum function, this will be adding the minimum function. And again, I'm going to put our ages, which as we just saw when we were doing our median, that 42 is going to be the minimum value. So we're adding the maximum and the minimum value, and then I'm going to come outside of my parentheses and then divide this by 2. So that will end up taking our maximum age, adding it with the minimum. And since I put that in parentheses, it's going to do the addition first. So, you know, we're using order of operations. It's going to do the parentheses first, and then it's going to divide by 2. And you can see our mid-range is coming out to be 60, which makes sense, right? Because you're taking 78 plus 42, which will add up to 120. Divide that by 2, which will end up giving you 60. So 60 is going to be our mid-range. And you know what? Let's go ahead and delete this so we don't get confused with that. So that's going to be our mid-range, guys. So remember, all 4 of these calculations are talking about an average. And you can see how each one of these calculations gave us a different number. Now, they're kind of in the neighborhood of each other, but, you know, obviously, they're still pretty different numbers from each other. So that's going to be our measures for central tendency. Now we're getting into how spread out our data is. So, you know, what's the dispersion? So let's talk about range. And we actually used the range calculation last week when we were designing our frequency distribution table. So this is still the same calculation here. You take your maximum value and you subtract your minimum value for it. So I'm actually just going to go back to the mid-range formula, and I'm going to copy over my max and minimum formulas. I'm going to come down to my range. Okay. Didn't mean to do that. Come down to my range. And I'm going to paste that. And then all I'm going to do is subtract instead of add. So maximum minus minimum. And that should give us the difference between 78 and 42, which of course comes out to be a difference of 36. Now, again, I told you you need to round your answers to 1 decimal places so you can add a decimal if you like. But if these are whole numbers and you want to leave them at, you know, whole numbers, that's fine. But anything like this guy, especially because this was, remember, 55.51111 repeating. So this type of number, you definitely want to round to the nearest 10. So that's our range. So it's telling us that, you know, the difference between the largest data value and the smallest one is 36, which by itself really doesn't tell us a whole lot. We're like, yeah, okay, there's a decent spread between our numbers. So what the standard deviation calculation does, guys, it's actually also an average, but it's an average of the distance of each of the numbers away from the mean. So you can see our mean is 55.5. And if you look at the traditional calculations for standard deviation, you will see each one of them will have you taking the data value, subtracting the mean from it. So you would literally, like, you know, if I show you here on our table here, you would take your data value and then you would subtract your mean from it, which is 55.5. Oh, I knew I had left something out. Okay, this number minus 55.5. copy that down. So as you can see, if the number is smaller than your mean, which is going to be all of these numbers here, you are going to get a negative value in that difference. When the number is larger than the mean, so anything larger than 55.5, you can see all of this came out to be positive numbers. Now, what's going to happen here is when I try to add this column here, you can see I'm actually surprised this came out to be 0.5. Normally these numbers come out to be 0.00000. And you will see that as you go through some homework examples in my stat lab. Yeah, B1 to B45. Yeah, so we're getting 0.5. That's interesting. So a lot of times what happens is we are unable to do these calculations because your total will come out to be 0. Because, you know, we're trying to find out what is the average distance that your data values are away from the mean. That's basically what standard deviation is. So because our total usually comes out to be 0, we are not able to use, you know, our traditional method where we add up all the numbers, divide by how many numbers we have, and, you know, go on our way. So what you then end up doing is you go ahead and square each of these numbers. So once you've done the difference, you did the subtraction, then you go ahead and square each one of those. And you know what happens with square, right? Negative times negative becomes positive. So all your negatives disappear. And then when you end up adding, and I'm just going to move this formula here so you will see it will end up adding this column for us. You can now see our number came out to be like 2,431.25. So that's a better number to work with. So now, once you get this total over here, I'm going to go ahead and paste it a little bit higher. Okay, it didn't transfer. So we are going from C1 to C45. Okay, so there's your total. So once you get the total of these square numbers, then you go ahead and divide this. And since we are working with a population over here, guys, because remember, these are all the ages for all the US presidents, right? So this is not a sample, this is a population. So you actually have two different formulas when you're working with standard deviation. So since this one is a population, you take the total of your square column and you divide it by n. And this is when you are working with the population. If you were working with the sample, so, you know, let's say you were only using 20 ages out of the 45, you would take the total of your data value minus the mean, which we squared, and you would divide it by n minus 1. This formula that I have up here is typically what we call as the variation formula. If I put a little square root on that, it becomes the standard deviation formula. So for the population, this one is going to be, you know, we took the data value, we subtracted the mean from it, and then we squared that, and we're dividing it by n, and then you take the square root. This will become your formula for the population. And, you know, this is actually not the formula that we use. You will see in your textbook, they talk about an alternative method or a shortcut method. I definitely recommend you guys to use that because it makes your life easier. It goes a lot faster than actually doing it with this traditional formula. But I'm just showing that to you for, you know, just an idea so you know what it looks like. So I'm actually going to go ahead and clear this out. So we took our total for the square column. Now I'm going to go ahead and divide this number by our total data values, which remember we have 45 of those. This is what we call as the variation. So again, this is a calculation for dispersion, how spread out our data is. For the standard deviation, I'm actually going to take the square root of this number, which is our variation. I'm going to take the square root and that gives you your standard deviation. So this is telling us, this number 7.350 is actually telling us that on an average, each of our data values, so each of these ages are approximately 7.35 units below or above the mean. Below, if the number is smaller than the mean, and above if the number is larger than the mean. So the standard deviation is a calculation which tells us what is the average distance of our data value from our mean. And that's how we actually talk about, is your data spread out more? If the number is large, your data is too spread out. If the number is small, your data is closer to the mean, which means it's more consistent. It's not quite as spread out. So that's what this measure of dispersion does. Okay, so we came up with 7.350. Now, if you use the built-in function for standard deviation, let's see what that comes out to be. So you will see here in the description, I'm telling you, you have to use .p or .s depending on, are you using the population or are you using the sample? So since all the ages of the precedent is our population, we will use the .p, and then I'll show you when you are supposed to use the .s. So equal to standard deviation for .p. So this is the one you're going to be using. And then here again, we're going to type in, did I lose that? Yeah, I did lose that. Oh, we're going from A3 to A47, I believe. Yeah, A47. So A3 to A47. And you can see this is coming out to be 7.4. If I round this to 1 decimal place, that also comes out to be 7.4. So again, your built-in functions do the formulas that are, given to you in your textbook, in your handout, whatever it is. So as you can see, these calculations work out. So this is just the first part of the assignment, guys. Your next part is actually going to be a little bit more time consuming, and this is where you guys will need to spend more time at. So once you do all of these calculations for all of the ages, then we are actually going to create our own random sample of 10 ages. So I've given you instructions here. You have to select a random sample of 10 ages from this list above. You can use random sampling techniques that you saw in chapter 1, or you can use the random number generator at random.org to choose your random numbers between 1 and 45. And again, you're doing between 1 and 45 because we've got 45 ages over here. So let's see how you can do that. To fasten up the process, I would probably go down here to the integer generator. However, you do have a random number generator over here. You can just put the number from 1 to 45. And whichever age you want to choose, that number will show up here. So pick the age which is in the 9th position. And in the 9th position, this will be the age, the 68 on that first row is in the 9th position. So that would be your age that you would select. Or like I said, if you want to fasten up the process, go to the random number generator. We want to generate, actually, we do want to generate 100 numbers between 1 and 45. You can do this in a column of 10 if you like. Get your numbers. Okay, so you can take the first one to come up with your random ages over here. So basically, the age which is, remember, these are not the ages, guys, these are the positions. So the age which is in the position of 32. Now, if you want to use this table, remember the first two cells are being used by these headings. So technically, when you see the age in the position of 32, in this table here, it's actually going to be in the position of 34. Or you can go over to this template here, and you can find the age in the position of 32, but actually I don't want to sort this. Okay. I may have to copy this over because you don't want to sort it out when you're doing this random number generator. So you do want to put this back into the order that it was in. Okay, so once you have it in the original order, then you can find the number which was in the position of 32 and looks like age 60 is in the position of 32. So that age 60 will go in here. Then our next one was 14. So the number in position 14 is 48. So 48 will go here. Then we have number 3 in the next position. So let's see, in the number 3, your age is 57. 57 will go here. Let's see, 41. So this is the part, like I said, can be a little bit time consuming. 41 is age 46. 46 will go here. Let's see, 36 will be age 56. 23 is 55. 45 and 35 for the next one. So let's see. Oh, yeah, that would be the final answer. So 45 is 78. 35 is 55. So 78 and 55. And then our last two ages will be in the position of 31 and 8. Let's see, 31 is 51, 51 and 54. So you have to repeat this 9 more times. So because you're creating a random sample from the given ages over here, and you will be doing this 9 more times. So you can see in the instructions here, I'm telling you to start out with a random sample of 10 ages. Once you have chosen your 10 samples, then you actually calculate mean, median, mode, mid-range, standard deviation for your sample. And then you repeat this process 9 more times. So that's why you're doing this a total of, 10 times. So once you have your random samples, and you can do the random samples first, so get all of these numbers first if you want. And then you can come back and calculate your calculations, the mean, median, mode. So again, I'm asking you to do a count here again, because unfortunately, one time I had a student who I guess didn't realize, and for some reason ended up deleting some of these rows. So I think they had only 8 or 9 data values instead of 10. So this way, when you count your number, you will be sure that you have a total of 10 data values here. And then, of course, use your built-in functions to calculate your averages, your dispersion. So the average for this data set is coming out to be 56. The median, that should not be 13, that should be 12. So F3 to F12, there's your median, which is 55, your mode. And again, guys, I always ask you to use the multiple mode, no matter what. So use the multiple mode. And this one is unimodal, so you only had one mode, which is fine, right? If you had more, it would list that for you. And if you end up with multiple numbers, which will actually show up down here, kind of like I did here, just separate them by commas like I put it down. So just go ahead and put it down here. Then your mid-range. Now remember, for your mid-range, we have to kind of put our own formula in. So for mid-range, you will do the max function. which will go from F to sorry, was it F3? Yeah, F3 to F12 minus the minimum function, again, F3 to F12. So this will, sorry, I did minus, that should be plus. So this will be adding our lowest and highest data values. And then remember, you divide that by 2 to calculate your mid-range. So our mid-range actually is coming out to be a fairly large number compared to the other 3 calculations. Your range, of course, is maximum minus the minimum. So maximum minus the minimum for these 10 data values, a range of 32, and then your standard deviation. Now here, guys, is where you have to be careful about when you do your standard deviation. Remember, this is a random sample of 10 ages from this 45. So this no longer is your population. So you do have to use the .s function over here. And that's going to be for, again, only these 10 data values. And you can see when we did a random sample of 10 ages, compare your mean median mode from these sample to the mean median mode of the original data set. So you can see our mean and median are still pretty close to each other. Mode just went up a slightly bit higher. Mid-range went up a slightly bit higher, and standard deviation also, went up a bit higher. Range went down. So, this will keep changing as you keep doing these new samples. So the more samples you get and start doing these calculations, you will see each one of these data sets, is going to have a different mean, median mode, mid-range, range, and standard deviation. Once you get all of these samples and calculations done, then the other thing you would be doing is calculating the mean of your sample means, which means you will actually be calculating the mean of all of these means that you calculate over here. So, again, you can go in, use the built-in average function, and this time just go ahead and select all of these means from here. And calculate and see what that number comes out to be, which I don't have any numbers except the first one, so that's what it will come out to be. But you're supposed to find the mean of all of these sample means, and then you will actually be comparing this mean of sample means here with the mean from all the ages to try and see, are they same, are they different, what do they tell you about the data set. So once you are done, you will calculate the mean of the sample means. Then you are going to make a comparison of how close the mean of the sample means is going to be to the original mean for all the ages. And why does this make sense? So once you're done doing that, then you are comparing all of your calculations. What conclusions can you draw? Looking at, measures of central tendency and measures of dispersion. What kind of conclusions can you make? So, for some of this, guys, you will need to read the textbook. You will need to look through the handout to try and understand, how we use these calculations to make these conclusions. So the template file that you have over here is pretty much the same one that I was just working on. I just made a copy of it. But remember, on the first page, you will have the original data set. And then when you go click on the second tab, you will find your template over here. Okay, so this is the file you will be working with. And some of you brought this to my attention this past week, that when you try to download the Google Sheets file as Excel, you sometimes lose a little bit of your data. So I would say download it as an Excel file before you start doing your calculation, so that when you're submitting your Excel file, you don't lose any data at the end. If it's going to lose, you can lose it at the beginning and redo it, instead of doing all the work and then downloading it. So if you're going to be working in Excel, guys, download your file first and then start doing the calculations. Now, if you are going to be submitting the Google Sheets as part of your assignment, apparently D2L does not let you attach Google Sheets as an attachment. So just include the link of your file in your comment section under assignments in D2L. So apparently Google Sheets and D2L have some trouble communicating with each other. And then, again, your conclusions are going to be recorded in Flipgrid. And I did make sure that this was not a view only topic. I guess I'll join with Google. Yeah, so you can see it's giving you the option of adding a response. So it will not be view only like last time. So your observations, conclusions are going to be in a video recording, and then all of your calculations will be on the template file. And again, guys, as always, your deadline is Saturday for this. So Saturday, April 9th, you can submit this. And like I said, if Google Sheets is not letting you attach it to D2L, you can go ahead and include the link of your file. So, if you go here to the top where it says share, just make sure when you are making your settings happen, I have the editing feature attached to it. Don't make me a viewer, because then I cannot see your calculations. And I need to be able to see your calculations. So make me an editor, so at least I can see what calculations you use to come up with your data values. So just please keep that in mind if you're submitting as a Google Sheet. So any questions coming to mind about this, guys? Anything that you are kind of potentially seeing might be something you need help with, or anything that I can help you answer questions? Lourdes, are you still with us? Yeah, go ahead, Montserrat.
So I was noticing how there was like 10 rows, right? And then I remember when random sampling, you can pick the same number twice. Is it by sample or is it in the whole sheet? If that makes sense.
Say that one more time.
So like, remember how like with random sampling, you can't choose the same number again?
Yeah.
I think, would that be by row, or would that be in the whole like table?
By the row, I suppose it could be, because with random sampling, we have no control. So like if you look at the numbers we generated over here, you will see that within the same column, I have the same number repeating, right? Which means they will feed to the same age, and that's fine, because you don't really want to modify that, because if we put our own changes in there, it will actually mess up with your calculations.
Okay, so I should, even if it repeats, I should just do the number that it's like choosing, right?
Yeah, I mean, even if you have 3, 4 occurrences of the same number, that's fine, because what's going to happen is if we mess up with our data values here, it can actually mess up with our mean calculations, which will mean this number will be affected over here.
Okay.
Yeah, so it's okay if you guys see repetition, because then that's why we want to use a random number generator table here, guys, so that way we have no control on how these numbers come out to be, and you will get the best calculations that way.
Okay.
Right. Yeah, great question, Montserrat. Yeah, thank you.
Thank you.
Any other questions coming to mind, guys? Okay, well, I'll be here for the rest of the week. So as you work on this and you run into any problems, definitely let me know, shoot me an email, and I'll be happy to help you out. So like I said, this one will be a little time consuming, because you have to come up with those, 10 columns of data values. So work on that, get that taken care of, and then the calculations will go quickly because you're using the built-in function, so you're not having to do those calculations by hand. But take some time, work through it, so that way if you run into any problems, you have a chance to ask me questions for it. Okay. All right, guys, if you have any questions, stay back and I'll be happy to answer them. And if not, then I will see you next week. Don't forget to request your exam password. Have a wonderful week, guys. Be careful. Stay safe. Bye, everyone. Hey, Ian. Lourdes, are you there?